start talking about the law of conservation of mass and just go through your notes with you. Before you start anything, I would suggest getting 4 different colors of markers so that when I go through the diagrams, you can draw the diagrams with me. All right, let's start. So the law of conservation of mass says that in any chemical reaction, the final mass of the products is always going to be equal to the original mass of the reactants. And so what that means is a chemical equation has to be balanced. You can't add or lose mass. One side has to equal the other side. And so another way people like to say this is matter can neither be created nor destroyed. When we talked about energy, we talked about similar concepts. Energy can never be created nor destroyed. And then it says if we were to get nitty gritty with it, the atoms on one side of the equation must balance with the atoms on the other side of the equation. That's what we're going to start talking about today. We're going to talk about how to balance an equation, how to tell if an equation is balanced, as well as the different types of reactions that there are. All right, so let's look at this diagram. I've got a couple of things. Over to the left, I have an arrow pointing to that 3. In the middle, I have an arrow that's pointing to the other side of the equation. And then I've got a small 3, and I've got my entire left side, my entire right side. And so these are the terms that you need to label using your notes. So the big 3 is going to be our coefficient. And what a coefficient is it tells us how many of those molecules there are. So that's copper chloride. There are 3 copper chloride molecules in that on that side. The arrow, it will be written as yields or produces. You'll see that sometimes. And so the left side is making what is on the right side. And then if we go to our right side, there's one on the left, but there's also one on the right. The small numbers below, those are called subscripts. Sub means below, and it tells you how many individual chlorines there are in that compound. And we've been working a lot with subscripts because we've been looking at bonding. Your left side is going to be your reactants. Now, sometimes you can have one reactant, or you can have a couple of reactants. Okay, your right side, so to the right side of the arrow, that direction the arrow is pointing in, is going to be your products. You could have one product or you could have a couple of products. So your reactants react to produce your products. All right, let's go and look at the next thing. So say I start with this chemical equation. And it's written and said as 2NaCl. I'm sorry, it's written as 2Na plus Cl2, and it yields 2NaCl. And it gives me this question below. It says I start with 8 grams of sodium and end up with 22 grams of sodium chloride. How much chlorine reacted with sodium? And so I want you to think about it for a second. Pause the video and see if you can come up with how much chlorine reacted with sodium in order to produce 2 molecules of NaCl. All right, so let's talk. I start with 8 grams of sodium, and so that's the total amount of sodium that I have on my left side. And it tells me that I made 22 grams total of sodium chloride. And my question's asking me, how much chlorine do I have? Well, because of the law of conservation of matter, this whole side has to equal this whole side. And so in this case, there's only one product, so it's pretty easy. What plus 8 gives you 22? And if you said 14, you would be correct. So 8 plus 14 grams gives me 22. Does 22 match 22? Yes, it does. So you have demonstrated the law of conservation of matter. What if I told you the answer was 12? Well, does 8 plus 12 give you 22? No, it doesn't. All right, so both sides have to be equal. Otherwise, you are gaining or losing mass. Okay, and so now I'm going to flip to my document camera so you can see. We're going to look at some atoms. All right, let's look at this. And so on your notes, you have this part that talks about counting atoms. And so a lot of them you already know how to do. So I want you to pause the video and I want you to try and do all of them on your own and then come back and see if you did them right. I would suggest writing with pencil. All right, so now that you're back, I'm going to go through the ones that you should have known how to do based on what we did with chemical bonding. So you should have known how to do this one. You list all your atoms. There are 9 carbons because there's a subscript of 9. There are 6 hydrogens, and there are 4 oxygens. Okay, this one doesn't have a coefficient. I'm going to list everything first. There are 2 hydrogens, 1 carbon, 3 oxygens. I'm going to skip this one for just a second and come back to it because it looks a little different than what we've looked at before. Here, I've got 1, because there's an understood 1 down there, 1 iron and 2 sulfur. Let's skip this one, come here. There's 1 aluminum and 3 chlorines. And now the rest of them, you might not know how to do, okay? And so let's chat real quick. Here, I've got a coefficient. And so that means there are 4 different molecules of this substance. Let's talk about water, because that's the easy one to draw. So when we draw water, there are 2 hydrogens for every oxygen. So that's 1 water molecule. Now this says that there are 4 water molecules. I've drawn 1. I'm going to draw a few more. 2, 3, and 4. And now notice, they're not touching, so they're not bonded. Okay? And so this is saying that there are 4 water molecules. So from here, you should be able to tell me, okay, well, there are 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And there are 1, 2, 3, 4 oxygens. But do you want to have to draw them every single time? No, you don't want to have to draw them every time. And so if you think of the coefficient like you would think of it in math, where if I gave you 2x, that's an x plus 4 plus y, just add that on there for a minute. The 2, if it's in the parentheses, it gets distributed. So I distribute it here. It's 2 times x, that gives you 2x. And then 2 times 4, that would give you 8. And then it doesn't go to this y because this is a whole nother thing. Okay? And so if I come back up here, pretend, because this is all here, pretend there's like an invisible set of parentheses right here. All right? Same concept. Except I'm distributing to the subscript. So 4 times 2 gives me 8. 4 times 4 gives me 16. And 4 times 2, again, will give me 8. So you're distributing and you're multiplying every time. Going to this one. 2 times 3 gives me 6. 2 times 1 gives me 2. 2 times 4 gives me 8. And so if you have a coefficient out front, it multiplies to everything right here. I'll go back and talk about this one, why the plus here in a little bit. Then we get to our last ones. Now this looks a little funky, okay? So this 3 is going to get multiplied by to everything behind it, every single thing behind it. But do you see how this is in parentheses right here? This 2 gets distributed to everything in front of it that's in the parentheses. And so magnesium is not in the parentheses, so all it will have is a 1. So 3 times 1 is 3. And if I look here, I'm going to go 2 times 1 gives me 2 times 3, because it's behind it, will give me 6. And for the O, see if you can figure it out first. 3 times 2 gives me 6, times 3 gives me 18. All right, let's do the next one. Same concept. C-A, A-L, and O. 2 times, there's an invisible 1 there, gives me 2. 2 times, well, I'm sorry, 2 times the invisible 1 gives me 2. Times 2 will give me 4. 2 times 2 gives me 4. Times 2 gives me 8. Okay, and that's the basic part of counting atoms. You have to be able to count atoms in order to balance equations. Okay, so let's go talk about balancing equations and what kind of equations we will see. Our first type of equation that we will see is called a synthesis reaction. And to synthesize means to combine two things. And so this occurs when two substances combine and form one new compound. And so if I wrote it in letters, I would have A plus B, and that would yield AB. And this is where I like to get the markers out and just kind of draw what that would be. And so if I draw this, I've got an orange plus a green, and that would give me an orange and a green together. They're bonded now. And so I start with two individual things, and I end up with one thing combined. And so there are a couple of examples down here. I'm going to draw one for you. All right, we're going to look at the first one. It says 2H2. And so if I were to draw H2, I'm going to underline this in the color that I'm drawing in. And I'm drawing in orange. So anywhere you see an H, it's going to be orange. So on both sides, it'll be orange. And anytime you see an O, I'm going to know that that's green. That way you know what I'm looking at. All right. So when I draw this, H2 means there's two oranges bonded together. But if we look, it's got a coefficient. So there are two H2s. There are two separate molecules that are hydrogen, okay, that are H2. So there's one. Here's another one. They're not all bonded together because this 2 tells me that they are just in the same container together. All right, so I have 2H2 plus O2. So just one O2, two oxygens. So a single plus a single, and it's going to give me a combination of those two. And it tells me, it gives me 2H2O. So two H's and one O. Now, how many of those do I have? That's right, I have two of them. One. And that makes two. Okay, so I start with a single, I start with another single, and I end up with them combined together. Okay, now these two things aren't combined together because then it wouldn't be water. But single plus single gives me them bonded together. Let's see if this obeys the law of conservation of mass. And so if it were to obey the law of conservation of mass, the number on my left should equal the number on my right. Okay, there are 4 green, 4 oranges. 1, 2, 3, 4 oranges on the right. So 4 oranges on the left, 4 oranges on the right. There's 2 greens on the left and 2 greens on the right. So this one, check, it's balanced. All right, so let's talk about what to do if it's not balanced or how to balance an equation. So we're going to use this one as an example. The first thing you do is you draw what I like to call the river, and you list out on each side all of the elements. And I would highly suggest that you write them in the same order on each side so that you don't get confused. All right. Here's what you do first, after you've done that, not first. You count the number of atoms that are on each side. So how many magnesiums are here? There's 1. There are 2 oxygens. On the right side, there is 1 magnesium and 1 oxygen. Do my magnesiums balance each other? Yes, they do. What about my oxygens? No, they don't. So in order to balance, I can add a coefficient in front of each compound. And on your notes, there have been lines that have been drawn. So this is a compound or a single element. This is a compound molecule, and this is a compound. Okay, and I've drawn the lines where you can add them. So you add coefficients, and then you recalculate. So can I make this 1 into a 2? I can. If I put a 2 right here, watch this. I'm going to recalculate. 2 times the 1 for magnesium because it did go with magnesium. I'm going to cross this off and put a 2. Okay, I don't care if you erase. I wouldn't erase, that way I have my beginning in case I mess up. All right, and then 2 times the 1 that is here, that is 2. Well, is it balanced now? No, it's definitely not balanced now. Okay, I would come back over here and have to balance my magnesiums. And all I do is put a 2. And now it is balanced. And it doesn't matter if all of these match, the magnesium has to match the magnesium. All right, and so while we're sitting here, if I had given you this as my final answer, would that be correct? So this is partially correct, okay? And so if you look at this, it's not simplified. I can pull a 2 out of all of these. So if I pull a 2 and divide this by 2, it gives me 2. If I divide this by 2, it gives me 1, which is always understood. We don't have to write that. And then the same thing with the 4, it would give me 2. So this would give you partial credit. Make sure that everything is in simplest form as you move on and you move forward. Okay, and so what we're going to do is we're going to continue balancing as we go, but we're going to learn about the different types of reaction. So our next reaction that we have is called a decomposition reaction. And in a decomposition reaction, one compound breaks down into elements or smaller, simpler compounds. So if you think of like decomposing, things are breaking down. So I start with one thing, pretend A, B, and it breaks down into A plus B. Now, on the left of this arrow, the yield sign is going to be my reactant, and here I only have one reactant, and that's okay. But I have a couple of products, so don't let it fool you. The left side is going to be your reactants. The right side is your products. The reactants react to produce the products, right? Another way to draw this would be to draw A, B, gives me A plus B. So one thing into 2 separate things. All right, let's move forward. Okay, and so I have the same type of equation, right? Let's see what color we made our hydrogen before. We're going to stick with the same color scheme. My hydrogens, anywhere you see a hydrogen, is going to be orange. Anywhere you see an oxygen, it's going to be green. So I have H2O, but I have 2 of them, and there are 2 that are not combined. H2O. And that's going to give me 2H2 plus O2. Okay, and so let's check to make sure this obeys the law of conservation of mass. 1, 2, 3, 4 on the left. 1, 2, 3, 4 on the right. There's 2 greens on the left. There's 2 greens on the right. And so that is balanced. But this is decomposition. I start with one compound. Even though there's 2 in the same jar, if I was just to look, I start with one single thing, and I end up with one single thing by itself and another single thing by itself. Okay, let's balance this next equation. And so remember, I would draw my river first. I'm going to list all of my elements in the same order on both sides. I'm going to count my molecules, count my atoms. 1 nitrogen, 3 hydrogen, 2 nitrogen, 2 hydrogen. Okay, and then I'm going to start adding coefficients. Now, when you look at this, I look at this personally and say, I'm not going to touch the 3 and the 2 just yet. I'm going to start somewhere different. Now, you can start here if you want. That's up to you if you know how to do that. All right, I'm going to start with the easy one. I can easily turn this nitrogen over here into a 2 by adding a 2 in front of that compound and recalculating. There are now 2 nitrogens, And I just didn't do the nitrogen. It also affects the hydrogen. And there are 6 hydrogens. Okay. Am I finished? No, because now my hydrogens don't match. And they never matched before. How do I make this 2 into a 6? That's right, by adding a 3. So that gives me 6 on that side. And so have I balanced my equation? Yes, I have. Let's check to make sure it's in simplest form. 2, 1, anytime you have a 1 or any prime number like 3, it's going to be in simplest form. Okay, now I want you to pause the video. I want you to tell me if these are balanced or unbalanced and tell me if they're synthesis or decomposition, and then come back and check your answers. All right, this one right here, I'm starting with 2 separate things. I'm making it 1, so this is synthesis. And if I count my atoms, 2 nitrogens, 2 nitrogens, 2 oxygens, this goes with this, 2 oxygens. This is balanced. Okay, next one, I start with 1 thing. I end up with 2 separate things. Okay, yes, I have an O here and an O here, but they're 2 different things. If you start with 1, you end with 2 things, then it's going to be decomposition. And let's check to see if it's balanced. I have 1 Ba on the left, 1 barium on the right, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, and look, 1 oxygen plus 2 oxygens, and that gives me 3 oxygens. So this one is actually balanced. You have to add these 2 together. All right, next one, 2 separate things to make 1 thing. This is synthesis. And very clearly, it is not balanced. So this is unbalanced. Okay, and then your last one, I start with 1, I end up with 2. This is decomposition. And this is not balanced either. Okay, and so right now we've talked about synthesis and decomposition. Taking 2 things and making them 1 is synthesis. Taking 1 thing and breaking it down to smaller pieces is decomposition. All right, let's go to our next part. So we're almost done. We have 2 more types to go. Single replacement is exactly what it sounds like. When 1 thing, because that's what single means, when 1 element replaces another in a compound. And so what this looks like is I have A, B plus C. So 1 thing bonded plus a loner over here. And that's going to give me A, C plus B. So it's replacing. It's kind of like when people are at a dance and they're lonely over here and they're like, I'm going to go cut in on that dance with this girl and I'm going to replace her, or guy, and I'm going to replace him. Okay, let's draw it. Just a real simple drawing. I have an orange and a green together. I have my purple. The purple's hanging out all by itself over here, and she gets lonely, and she's like, nope. Or he gets lonely. I'm going to go replace the orange. And now he or she is dancing with the other one. And it leaves the orange all by itself. Okay, so that is single replacement. 1 thing is replacing another. Okay, let's draw this as we were doing in molecules. And I'm going to do a little line so you know what I'm drawing and what it goes with. All right, anywhere I see copper, it's going to be green. Anywhere I see chlorine, it's going to be orange. And anywhere I see aluminum, it's going to be purple. All right, let's start drawing. CuCl2. So Cu, there's just 1. Cl, I'm not worried about the bonding angles right now. I'm just kind of drawing them so you can see and count. Okay. Plus 2 Als. Now, they're not bonded. They're just existing in the same place. 2 ALs. 1, 2. Okay. That's going to give me 2 AlCl3. So I have AlCl3. 1, 2, 3. And how many of them do I have? I have 2 of them. Okay. Plus 3 Cus. And because it says 3 Cus, they're just hanging out over here by themselves. All right, so I started with a green and an orange together and a purple by itself. And now it kind of might look like blue on your screen. And now the purple is bonded with the orange and the greens by itself. And so that is single replacement. Let's look at this one a little bit more, okay? If you look at this, is this balanced or unbalanced? We'll have the same number of purples on both sides, but if I look at the other ones, I do not have the same numbers of the greens, which would be chlorines, and I'm sorry, coppers, and the orange, which would be chlorines. And so I am going to go through and I'm going to balance it without adding any coefficients. And let's see if we can do that just by using a model, because you're going to have to use a model on your test. Okay. I know that my purples are unbalanced or balanced, so I'm going to add, let's look at our greens because that looks pretty easy, okay? So I know I'm going to have 3 greens over here. I only have 1 right now. So for every green I add, because it comes as a package deal, I'm going to add 2 oranges. 1, 2. Okay, I'm still not balanced because I need another green. And again, it comes as a package deal. For every green you have to add an orange because there's a set specific ratio that they bond in, okay? And so it's a 1-to-2 ratio. For every 1 copper, you have 2 chlorines. And let's look at it now. I have 3 greens over here, 2 purples, 1, 2, 3, 4, 5, 6 oranges, 1, 2, 3, 4, 5, 6 oranges. And so now, in order to make this a true statement, I need to write in the coefficient. And the coefficient in front of this should be 1, 2, 3, should be a 3. And now, that's all you had to do to balance it. And so because you added these yourself, you didn't have to do all the coefficients and figure that out, but you could do the coefficients and figure it out. You need to know both ways. All right, let's balance this one. Again, draw the river, list your atoms, and list them in the same order on each side. Because if this is one of the ones that you would make sure, because if I were listing in order, it'd say Cu, C, and O, and it would kind of, this should be Cu, throw me off. There are 2 Cus, there's 1 O, there's 1 carbon, there's 1 copper, there's 2 oxygens, and 1 carbon. All right, pause the video and see if you can balance it, and then come back and check your answer. All right. I am going to choose to start. You can start wherever you want. Obviously, don't start with carbon because carbon's already balanced. I'm going to choose to start with, going to balance. I'm going to show you if you would, there's 2 different ways to do it. I'll start with balancing the Cu just because, okay? I'm going to put a 2 here. That gives me 2. Those are now balanced, okay? I now need to balance my oxygens by putting a 2 here. Now make sure you recalculate. This gives you 2 times 2 gives you 4. 2 times 1 gives me 2. Uh-oh. Now my coppers aren't balanced anymore. Can I make this 2 into a 4? Yeah, erase this whole coefficient and put a 4 there. Now you have a 4. So you could have started there. If you start there, it makes you have 1 extra step. If I would have started with my oxygen, I would have gone straight and put a 4 there. It doesn't matter as long as you get the end result. That's correct, okay? So let's check to make sure it's simplified. 2, 1, 4, 1, 1 and 1 are prime, so we're good to go with that. Okay. Here we go. Last little part, and then we're done. Okay. Double replacement. So similar to single replacement, except this time we're going to have double. We're going to have 2. It occurs when 2 elements swap with one another. And so here I might have AB plus CD, and it's going to give me AD plus CB. And there's a reason I wrote it like that. And so like for this one, it would be an ionic bond. I'm not going to draw all these out. I'm just going to kind of underline everything. I'm going to underline PB in orange or green. In O is a package deal. It's going to be in orange. K is going to be purple. And then I'm going to get my third color, which is red. Hopefully you can see the difference. And there we go. So the red and the orange were together, and the orange and the green were together, and the red and the purple were together. And now if you notice, the purple and the orange, see if you can see that a little bit better, have switched places. Not the purple and the orange. The red and the orange have switched places. All right. Last thing. So we've already worked on balancing equations, or not balancing equations. We've done that a little bit today. We've worked on naming equations and going from a name to from a formula to from a name to a formula. Okay, and that's what we're going to do here. And so you need to make sure that you have a periodic table out in front of you. Okay, and I want you to go and I want you to tell me all of the formula names. You need to check and see if they're ionic or covalent. And so calcium is a metal, chlorine is a nonmetal. This is ionic. Aluminum sulfide is an ionic compound. Looking at the names of all of these, you should know that they're ionic compounds. All right, and so I want you to just pause this, look at your periodic table, name them, or give me the formula, and then come back and finish the lesson with me. All right, calcium chloride should be CaCl2 plus aluminum sulfide is Al2S3. Aluminum chloride is AlCl3, and calcium sulfide is CaS. Check yours. Should be right. Okay, now what we're going to do is we're going to balance this. And so when we balance this, I'm going to get you to draw the lines in between these things right here. Let me point one thing out to you. When we balanced our very first one all the way back over here, and we were balancing down here, and I put the 2 in front of the mg. It did not go with the O, okay? Remember, it only goes with what is behind it. It's got separated by this plus sign. And so before I said I would go back up to this, remember, it's the same thing in math. This goes with whatever's behind the parentheses. I just want to make sure I told you that. Okay, last thing, and then we'll be done. Going to balance this. I'm going to draw a line. I'm going to list all of my molecules, atoms, in the same order: Ca, Cl, Al, S. There's 1, 2, 2, 3, 1 aluminum, 3 chlorines, 1 calcium, 1 sulfur. All right. Me personally, I'm not going to start with a 2 and the 3 just because that kind of gets in a little nitty gritty. I like to start with a 2 and the 1 because to me that seems pretty simple. I can make that work pretty easily. Okay. So if I start with a 2 and the 1, I know I need to come over here and make this into a 2 by adding a 2. That gives me 2 aluminums. I now have 6 chlorines. Okay. Now my aluminum's matched, my calcium's matched. I'm going to come back over to the left. I am going to make let's make my chlorines match real fast. Make my chlorines match. I'm going to add a 3 here. Okay. That gives me 3. Now I have 6 chlorines. And now both my chlorine and my sulfurs don't match. I can simply add a 3 here. And I now have a balanced equation. Okay. And so all of them don't need a coefficient if it's balanced. This one is balanced and it's in the simplest form. So we're going to practice over the next little bit. Please make sure that you are looking at your classwork on Google Classroom. If you have any questions, make sure you message me and ask.